Here's the 1.11 to 1.12 quiz. Before starting, oh, this is from Riyadh Chemistry MS. UARM, UARM. Memorize these like your name. URM, V constant, A is equal to 0. X equals VT plus X initial. UARM, V is increasing, or yeah, V is increasing. A is increasing. Show increasing, as they say. A is constant. First formula, V equals AT plus V initial U, which is U. Second formula, X equals half acceleration times time squared plus UT plus initial X. Third formula, X equals U plus V over 2 times T. Fourth formula, uh, V squared minus U squared equals 2AX. Screenshot whatever you want, memorize. That's all I'm gonna tell you. A cyclist, I'm telling you, you won't pass if you don't have these memorized. You won't pass. A cyclist speeds up from 5 meters per second to 25 meters per second in 10 seconds. Then he travels at 25 meters per second for another 10 seconds. So here, there's an acceleration. So it's UARM. Then he travels 25 meters per second. It's a constant velocity, so it's URM. What is the total distance? So we're splitting it up into two segments. Distance traveled in UARM and distance traveled in URM. The distance traveled in UARM, we want to see X, right? This is how you do it. I'm telling you, you enter the exam, you write the formulas down on a paper. This is what you're gonna do. You're gonna look at your paper, you're gonna see what do I have given, what do I want? And I want X. I have time, and I have A. Which one has X, A, and T? X equals half AT squared plus UT plus X. No. Okay, so X equals half AT squared plus UT plus X naught. Okay, so you're gonna use half the acceleration, which is this is, hold up. Acceleration is 2. Yeah, acceleration is 2. Wait, they gave you velocity, يا أخي. You should have put velocity. Look, okay, yeah, whatever. They gave me velocities, but this isn't characterized as velocity. They gave me the velocity in a certain time. Velocity in a certain time is acceleration. Can we find the acceleration here? Yes. Equals 25 minus 5 over 10, which is 2. Okay, time. So half A, T squared, 10 squared, plus UT. Initial velocity 5 times the time 10 plus X node. We don't know. We don't have an initial position. We just keep it as 0. Okay, you should get 150 here. Okay, plus the X of URM. URM, there's only one formula. It's X equals VT plus X node. So X equals the velocity 25 times the time 10. X node is 0. We didn't give it to us, so you just put 0. 250. So 150 plus 250, 400. Question 2. The speed of a bus traveling south is uniformly reduced from 54 to 36 kilometers per hour, okay? In a distance of 62.5. Give all answers to yourself. Okay, what's the acceleration? Okay, let's see. أول شيء find the speeds in the correct units. نحن want acceleration meter per second squared. So we should solve in meter per second. If you want to convert from km per hour to meter per second, you divide by 3.6. Divide by 3.6. 54 divided by 3.6 is 15. 36 divided by 3.6 is 10. Okay, 15 to 10. We want from 15 to 10. Okay, can we find the acceleration? We should be able to find the acceleration. Yeah, so now we want acceleration. We have the initial velocity u, we have the final velocity v, right? And we have the distance x. Which one has a, u, v, and x? V squared minus u squared equals to ax. Go back to your formulas if you want. This one, see? It has v, u, a, and x. So we're going to use that one. V squared is 10 squared. U squared is 15 squared. Keep the minus outside, huh? Equals 2 times the acceleration, we don't know it, times 62.5. If you solve this, you're going to get a equals minus 1. If the bus keeps decelerating at the same rate from 54 kilometers per hour, how long will it take to stop? 54 kilometers per hour is the same we said as 15 meters per second. You have to convert or you'll get the wrong answer. Okay, now we want the time. Okay, very easy. We want to go to stop. Yani v final is 0. We know acceleration is velocity final minus velocity initial divided by time. Final velocity 0 minus 15, because initial velocity is 15, over time equals -1. You're going to get t equals 15 seconds. The distance covered by the bus before coming to a stop. The distance, we want x, right? We have the acceleration in this phase, right? We have a. Why aren't you using v and u? ما يا أخي بديش v and u. And I'm talking about the accelerating, the stopping phase, okay? I have x, I have a, I have the time from part b. How can I, which one has x, a, and t? X equals half at squared plus ut plus x node. So half acceleration, which is -1, time squared is 15 squared, plus initial velocity, which is oh shit, where's initial velocity? Yeah, initial velocity was 15 meters per second, right? We started at 15 meters per second. Remember, we changed it to meter per second. You can't solve it kilometer per hour. So 15 times the time, 15, and x node is just 0 because like we started, they didn't mention it. Okay, so you're gonna get minus 122.5 plus 225. Oh no, this is 100 minus 112.5. Sorry. If you do this on a calculator, and you're gonna get this one. It's equal to 112.5. They set to 3 significant figures, so you can change to 113. Okay. Question 3. Okay. Here we have a velocity time graph. Okay, they're gonna ask you, is UAR or URM? أكيد if velocity is increasing URM. قصدي UARM ليه URM؟ UARM because velocity is increasing, so UARM, it's accelerating. B, it's URM because it's not accelerating, velocity is staying constant. Then here it's you're again, velocity is changing at a constant amount, so you say UARM. If they gave you the option to say UVRM, you'd pick it, but I don't think they would, so just ignore that for now. And then they say, what's the net displacement? Everyone's gonna say like, oh shit, okay, just do this distance, area of this plus area of this plus area of this. We can do this. Yalla, I'll show you. But the last part's a bit tricky because it goes down into the negatives. I'll show you what to do for that. Let's find the first area. Base 5 times height 0.6 over 2. You get 1.5. Here it's a rectangle, so length times width. Length times width. So the length is 5, the width is 0.6. Or base times, however, you get 3. And then here, this is the tricky part. It's a base, is 2. It's height. Okay, here's the thing. If it's half of it is in the positive side, half of it is in the negative side, you just add the 0.6 plus negative 0.2. Okay, so 0.6 plus negative 0.2. And we know it's base times height over 2 again. Okay, and you get 0.4. Okay, this is the case. But sometimes it would go هيك, or you know, no, it would be like this. It would be like this. هيك هيك هيك. They ask you to find the displacement here. Okay, here, since it's all in the negative, you just take the height would be, in this case, negative. Okay, it would like be, I don't know, negative 0.4. Okay, and then the base. Here it would you just take the height because all of it is in the negative side. But here why I added them is because half of it is in the positive, or like so a part of it is in the positive, a part of it is in the negative. So how we just add it up, 1.5 plus 3 plus 0.4, you get 4.9. 4. Okay, a rocket, and I really like this question here. A rocket is fired vertically from rest. You're gonna need it because we're using G now. Okay, we have the chapter of free fall. I'm gonna upload my notes. I won't make a video on the notes. Please make sure to read them. If you're not gonna read the book, at least read my notes for the free fall chapter, because there's not only free fall chapter, for all of 1.10, no, 1.11, 1.12, because we haven't done an AMS on it yet. So we don't know what type of memorizing questions they might ask. You know, when is free fall attained? Free fall is attained when there is no air resistance. And then they say, if two objects are dropped from the same height, if like, okay, 150 kilogram iron is, and 1 gram of feather is dropped at the same time, neglecting air resistance, which one will reach the floor faster? You'd say they'd both reach in the same time. Like these types of questions, and you need to read the book for them. They didn't ask in the quiz. So just to be safe, please make sure to read the book or read the quiz as they read my notes that I will be uploading soon. I didn't upload them at the time of recording this. It's Friday at 10:30. I haven't uploaded it yet. Alhamdulillah. Anyway, here, question 4. A rocket is fired vertically from rest, so u equals 0. With a constant acceleration a, 20 meters per second for time 80 seconds. So 80. It's then its fuel is all used up, and then the rocket continues going up until it stops because there's no more force pushing it. It's just eventually gonna stop. Neglect air resistance. In all questions, they will tell you neglect air resistance. USG is 10. What is the rocket's altitude? Altitude and displacement, or its position. 80 seconds. Okay, we want x given a, u, and t. What are we gonna use? Akid half 80 squared plus ut plus x naught. Let's see, x equals half acceleration 20 times time squared, which is 80 squared, plus u, it's 0, x0 is 0. So عادي. We just do this, is going to be 10 times, ما بعرف. You should get 64,000. Let me see. 0.5 times 20 times 80 squared, 64,000, which is the same as 64 times 10 to the power of 3. What is the speed after 80 seconds? So we want v. Okay, very easy. V, if you have, we have everything. The easiest one for v in UARM is just acceleration times time plus u akid. But our u is 0 in this case, so we don't need it. A is 20, its time is 80, and you get 1,600. So 1.6 times 10 to the power 3. What's the maximum altitude reached by the rocket? Okay, this one, it gets you thinking, because we have the altitude after, all this acceleration, and then they told us it didn't stop, it continued going up until eventually later it stopped. So we need to calculate this phase here, this phase of, so it went up and we're on 64,000 now, and there's this phase where it didn't it kept accelerating. Okay, so here's what we're gonna do. نحن in this phase, they told us that the acceleration is, they said g is 10. When you're going up, if you throw something down, what causes it to stop and come back down? Should throw something down, throw something up, I mean. If you throw something up, what force causes it to turn around and come back down? Obviously, that force is weight. And what is the acceleration of weight? G, which is in this case 10. In this case, weight is pulling you downwards. So in this case, G will be negative 10, or our acceleration will be negative 10, right? G is gravitational acceleration. So our acceleration is negative 10. ماشي. So we have our acceleration, okay? We have the velocity. We found it in part B, right? Velocity here. This is V. And we want, wait. Sorry, this isn't the velocity, this is u, this is initial velocity. Because if you want to look at the rocket, its initial velocity is what we had here, 1.6 times, like let's say I draw the rocket, okay, let's say هيك. Okay, and it's in the air. هلا it's at 1.6 times 10 to the power of 3 meters per second. Okay, it's gonna start slowing down, right, until it stops. So okay, this is my initial velocity. With the final velocity will be 0. So this is u. And then it's gonna stop moving eventually, right? When it stops moving, we want to know how much distance it traveled in total. Let's see. We have v, we have u, we have our acceleration. ونحن بدنا altitude again, so بدنا x. We don't have time. The only equation where you can find x without the time is v squared minus u squared equals 2ax. V squared, we know it's 0, so 0 squared minus u squared, which is minus, keep the minus outside. In these formulas, you keep minus outside. 1.6 times 10 to the power of 3 squared equals 2 times acceleration, which is negative 10, right? Times x. Let's solve this. So you're gonna get negative 1.6 times 10 to the power of 3. Yeah, we're gonna get minus 1600. Okay. Oh, shoot us the squared. I'm saying I'm missing something. Squared. Okay. And we're gonna divide by negative 20. Why did I divide by negative 20? Because some people are a bit slow. Because here 2 times negative 10 is negative 20x. Okay. So just take the negative 20x there and divide by it. I say not the negative 20x, just negative 20. Take it to the other side. And you get that x equals 128,000. طب وليد, here it's 192,000. ما حبيبي, look. They said the maximum altitude. نحنا we already reached 64,000. يعني if you want to like, here we already reached 64, let's just say k, 64k. We reached 64,000. And then we traveled 192,000, sorry, we traveled 128,000 more. So we added 128k. So أكيد here هلا how much is our altitude? 192k. Just add them in. Add this with this. As they add this with this plus. Okay, you get 192,000. Question 5. A motorcycle moving initially from the origin at 2 meters per second. So initially at 2 meters per second, so this is u. Okay, this is how I like solving. Wallah, and on my paper, on my scratch paper, as I solve, I write okay, u equals 2, and then I say accelerates. Okay, so a equals 0.4, and then time is 60. This is how this is how I solve. I know. Okay, the velocity of the motorcycle at t equals 30. So he switched up. But the region likes doing this a lot. Huh? He switches up a lot. So now t equals 30. Okay, so we're gonna scratch this off. Okay, they want the velocity. Velocity equals the easiest one if you have acceleration and time is at plus u. And in this case, it's gonna be 0.4 times. Please don't make the same mistake I did when solving the quiz. While solving the quiz, I used 60, but suddenly they want at t equals 30. So 0.4 times 30 plus the initial velocity u, which is 2, and you get 14. The average velocity. Okay, whenever I'm gonna tell you this, you're gonna see it a lot in this quiz. From now, if you ever see average velocity and we have UARM, that means you have to use the equation the average velocity is equal to final minus initial divided by time. You have to use this equation. Okay. So now we need the displacement. We need x. Okay, can we find x? What do we have? We have, like we said, we wrote here u equals 2. We have a equals 0.4. We have t equals 60. Can I find x if I have a, t, and u? Yes, I can. It's half at squared plus ut plus x0. Again, you just look at your formula sheet. You see what do I have? You compare it with what formulas you have. Okay, and see which one can fit. Okay, x equals half at squared plus ut plus x0. So half times the acceleration 0.4 times the time 60 squared plus ut 2 times 60 plus x node, which is 0. We didn't say anything about it being 5 meters from the origin, for example. Yani. They didn't say anything about that. Okay, so have 80 squared plus 2 plus x node. Some people are going to say, Walid, why do you use 60 now instead of 30? Because here they said 60. Okay, and you're going to do this. You're going to get, let me see, 0.5 times 0.4 times 60 squared plus 2 times 16. 840. So x is 840. Since x initial is 0, it's fine. Divided. Okay, hella, we want velocity. So it's going to be 840. X is fine minus x initial. Since x initial is 0, we just write 840 as the x. Divided by the time, which is 60 seconds, right? So 800, sorry. 840 divided by 60. 14. Question 6. This quiz is long. 9 questions. Okay, the acceleration of a particle constrained to move along a straight line is -6. Okay, A is -6. The way they worded this question really pissed me off. That's why I got it wrong. So initially, the particle is at x equals 1. So x0 equals 1 meter. Okay, if you want to be more like fancy, I should put You don't, يا أخي, forget I said anything. 1 meter. Okay. Moving towards the origin at 5 meters per second. Okay. If you're moving towards the origin, if you're ever moving towards the origin, that means you're going like this or you're going like this, right? Whenever you're moving towards the origin, are you slowing down? Yes, you're slowing down. So your velocity is decreasing, right? So the initial velocity is not 5, it's negative 5. Okay. The positive, even they said here, the positive direction is against the initial motion. So our motion now, it's against the positive direction. So if something is against the positive, يعني أكيد it's negative. So that's why my U is negative. Okay. They're saying what's the average velocity? That's part A. Like I told you, average velocity, anytime you see average velocity, you have to use delta x over t. X final is x initial over t. What's our final x? For the final x, usually x initial is given. If it's not given, insa. Forget about it. X final is always your x that you attain during the motion. How can I find x if I have a, u, and I also have the time? Which one do I use? A, u, and t. This is x node, sorry. This is x 0. Which one do I use? Half at squared plus ut plus x node. Right? Okay, so it's going to be half acceleration negative 6 times the time squared 10 squared plus negative 5 because my u is negative 5 times t is 10 plus x node, which is 1. See, here we actually have x node. It's given. Okay, so you're going to get negative 300 minus 50 plus 1. So you get negative 349. So my final x is minus 349 minus the initial x, which is 1, over the time, which is 10 minus 35 meter per second. Okay. What's the instantaneous velocity at t equals 10 seconds? At t equals 10 seconds. When they say instantaneous velocity, we want to find v. Okay, let's erase this. I don't. Okay, we want to find. Trying to do a band. Don't ask. Yeah, we want to find v. My bad. At t equals 10 seconds. Easiest one is v, especially when you have everything. We can just use v equals acceleration times time plus u. The acceleration is negative 6. The time is 10. With my u initial velocity is minus 5. So you're gonna get v equals negative 65 meter per second. Anna, why I got this question wrong is because I forgot to put u as negative 5. I kept it as positive 5. Please don't make that mistake. I saw 5. I said خلاص it's 5. Okay, I didn't read the toward the origin part. Okay, so please make sure in the exam you read every question twice, at least twice. This regional, I'm telling you, you guys saw with the physics periodic last week or whatever, 2 weeks ago, whenever it was, you saw that he got one question. He played with the words just a bit. 85% of the grade got it wrong, and they lost 10% just from one question. 10%. Haram, yani. Most people knew the answer, but they just read the question wrong. They just needed one extra step. So please don't make the same mistake, okay? How long does the particle remain in the positive side of the origin? This one, it's a bit hard, okay? I'm gonna draw it for you, okay? This is our x. We have 0 is the origin here. We start at 1. We want how long does it stay on the we know we're moving like this, right? We want to know how long we stayed on the positive side. So we're moving towards 0. So how long did we stay here? Let's see. We want to know the distance. We want like to know the time, right? Let's see. We want the time and we also want the x, right? Because the positive side of the origin, yani until x equals 0, right? Yeah, we want to know until x equals 0. How long did that time take to get x equals 0? Let's see. We want something that has x and something that has time. Okay, we have two. We have x equals half at squared plus ut plus x node, and we also have x equals u plus v over 2 times time. Why we can't use this is because we don't know what velocity he finishes at. We don't know. Okay, so you can use it, but like you need a few extra steps. So I find this way easier because we have the acceleration واضحة, and we have the u. Also, it's given. Okay, and we also have x naught. So let's just do this. X is 0, right? Half acceleration is -6 times the time squared. We're trying to find the time. Plus u, which is -5 times the time. Plus x naught, which is 1. Let's so let's solve this. Half times -6 is -3t squared minus 5t plus 1 equals 0. This is a quadratic. Get your calculator. Okay. Please make sure you have a calculator, guys, that can do equation mode. At this stage, everybody should have one. Okay. Really, it will help you so much. Okay. And you're gonna get 0.18, and the other answer would be negative. So okay, you can't have negative time. Question 7. Okay. A runner passes the start line at a speed of 1 meter per second. So u is 1. And he accelerates at 0.5. So a equals 0.5 meter per second squared. Okay. For 10 seconds, t equals 10. Okay. What's the displacement? So they want x. How can I find x having a, t, and u? Okay, x equals half at squared plus ut plus x node. So it's half 0.5 times 10 squared plus u, which is 1 times 10 plus x node is we don't know it, so we're just not gonna write it. Okay, didn't give it. So half times 0.5 times 10 squared is 25 plus 10. Just put it in your calculator, you get 35, guys. 35. Question 8. Okay, a student releases a small steel ball from a height hitch. Okay, so height hitch above a table. The ball hits the table 0.3 seconds. So t equals 0.3 seconds. G is 9.8. G, in other words, since we're talking, we're studying free fall, let's just keep it as G equals 9.8. In my notes, once I do upload them, if you do read them, I wrote that y equals half gt squared plus ut plus y naught. Why I changed x with y is because when we're talking about free fall, this is how we draw the graph. When we're talking about free fall, it's kind of like this, right? This is how, like, and this here is the y, the distance. We put it here, and this is the time. Okay, this is how, like, we kind of draw it. It's a bit weird, okay, but this is how we put it. Instead of going like this, no, we do it the other way around. Okay, so that's why we changed x with y, and with acceleration we call g, because now we're talking about gravity since we're in free fall. I'm just explaining it in case you do see it in the book and you start getting confused. I don't think they will listen, integrals they're in my notes. Okay, don't stress on them because I don't think he's gonna get integral. Okay, please don't stress on them, because we're not at a level where we are required to know integrals. Anyway, so here they want the value of h. H, in other words, they want x or y or whatever. Listen, in the exam, if you write x equals, yeah, I had to go get something, so I don't know where I am now, but I think I was saying x equals half at squared plus ut plus x node. That's the formula we're gonna use here. Okay, what we're trying to find is the height h, so that's why we're gonna replace it by x, right? X is meters, any distance, any height, you use x. Half the acceleration, which is 9.8, it's gravitational acceleration. Since there's free fall, we replace acceleration with g. Okay, times the time squared, 0.3 squared plus the initial whatever, this is all 0. Okay, so x equals mod 1 0.5 times 9.8 times 0.3 squared. You get 0.44 to 2 decimal places. Then here, okay. Here we have a student who is trying to obtain experimentally the value of g, of the acceleration g, free fall acceleration, whatever. What you need to obtain this value, you must memorize, and it's in the course revision document, which I will do a separate video on later. As of now, I don't think I'll record today. It's pretty late. I'll probably finish this and go sleep. Tomorrow I'll record. Anyway, we know that the acceleration is in meter per second square. That's the unit, right? If you see here, we're determining two things. We're determining the distance, okay? We're determining the time squared, and we're trying to find the acceleration, a or g or whatever. Which formula has h, or the distance x, let's say, time squared and a? When you see time squared, you should immediately know x equals half at squared plus la 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 la. We don't care about ut and x naught because we're dropping it from rest, obviously. X equals half gt squared. We can replace a with g. So now we want to find what g is. How do you find g? G would be multiplied with on the other side, 2x t squared. As the 2x over t squared. 2x over t squared, right? G equals 2x over t squared. So 2 times x over t squared. Let's take any point. We're going to take this point here, where t squared is 0.2. It's already in squared form, okay? It's already in squared. And x, x is over here. This is 0.05 each one, because 1 minus 0.75, 0.25 divided by 1, 2, 3, 4, 5 spaces. You get 0.05 each one, so this is 0.8, this is 0.85. Another one I want is over here. This is 0.8, 0.85, 0.9. So 2 times 0.9 over 0.2. Let's see. 2 times 0.9 divided by 0.2. You get 9. That's how you get your answer. Okay, just memorize this formula. G equals 2x over t squared. Okay, in case it comes. Thank you so much for watching. Good luck in your exam.